Please, a warm welcome to Detlef. That's the first slide. Hello, everyone. I work in BT's research organization, and I look after areas around data science and AI. And I'm giving you a short overview of what we do in general in AI, what we think is important in this area, and then have a bit of an overview of what we think interesting trends could be. So we use AI in the company for easily 20 plus years. And at any point in time, if you look into the research organization, we have lots of projects that you would classify as AI, so currently probably around 30. And one of the earliest adoptions is the way we run our workforce, so the engineers that go everywhere to install broadband or fix faults. This is a 20,000 plus workforce where we need to make sure that the right person goes to the right job at the right time, has the right skills, and so on. And this is kind of classical AI that nobody talks about anymore. This is the kind of AI that you see on your smartphone when you use Google Maps and you try to plot a route from A to B. It is search and optimization. And this is the kind of stuff that is in application, not just in our organization, but in many organizations throughout. And you hear other examples from my colleagues. You hear something about what we do with networks. For example, we have AI that helps us to plan the layout of networks. Cybersecurity, you have already heard in the morning. You hear more about it from Alex. The way we do things like nuisance call detection and all of this good stuff. So it's not new for us. One thing we realized is when you want to do something like AI, is quite hard in an organization. It's not about buying a tool and running some software to give you a machine learning result or something like that. You need to have several things in place. It's kind of, people say in terms of AI, like data is the new oil. Has something to it. The AI from today is fueled by data. And if you don't have good quality data, you can't do anything. And how do you get good quality data for your AI? You need to have the basic infrastructure in place. You need to be able to collect data and store it and move it between systems. And in a lot of organizations, data is trapped in operational systems, and you can't do anything with it. And when you then get it out of these operational systems, you need to be able to clean it, make sure it's of good quality, prepare it for analytics. And then you can start doing interesting stuff, like aggregating it and computing metrics, and then generate training data for your advanced algorithms. And then you can do things like machine learning and AI stuff on top of that. If the base of this pyramid is not in place, then you'll find that for each AI project that you want to do, you have to dig deep. You have to put a column in place that goes from the top of the pyramid all the way to the bottom. And you may end up with lots of pillars instead of a pyramid. So it's worth thinking about the base capabilities that you need in an organization and invest in them and put them in place. That's one thing that we learned. The other thing to realize is when you do data science, machine learning, AI, in a sense, you take data, you transform it by some algorithms to come up with a model that helps you to do some decision making. It could be something simple like marketing to send information to your customers, or something more complex to send an engineer to do a job. But when you think that through, what the kind of chain is that you're working is you go from data, you need to transform the data, you need to generate features that go into your modeling, and then you deploy this, you apply it to data, and you make some decisions. And in each of these steps, you can test. And if you know something about software engineering, it's what they do these days is called test-driven software engineering, test-driven software development. So before you write the first line of code, you think about the tests you want to do. What kind of stuff should your program be able to do correctly? And you write this down as tests. And you can do the same thing in each of these steps in this chain. So you can actually test your data. You can check if the data in your repository is correct. Is it complete? Is there bias in your data? after you have transformed it, you should do the same tests again because the transformation might lead to incorrect data. And so do you know where the data comes from? Is it something that somebody has put together for a report, or is it actually the ground truth that has been collected at the first instance? And then you build things that go into the algorithms. And again, you can make mistakes here. Feature generation is kind of the second step where you apply some software. You might write code, and you need to test this. The model building, if you have heard about machine learning, you know things like testing and cross-validation. So when you build a model out of data, you need to check that it actually does what you want it to do. So there's another layer of testing that you can do at this stage. And then you have hopefully a model and you have some idea how good it is. And then you go into deployment, and then things can go wrong again. And the data that goes into your model might not be of the same structure that you have used to build your model. So you might apply your model to something it has not been built for. So the results that come out of your application might be wrong. So you need to check that. And then it goes into decision making, and then hopefully this has some impact on your business and leads to some positive result. But again, this has to be checked. And this is where you do things like A/B testing, keeping control groups to make sure that the effect that you're having is actually the intended effect and that it's actually in a positive way different from random behavior. So it's actually quite complex, and typically vendors who want to sell you a machine learning solution don't tell you these things. Then when we look a little bit into what might happen, I found this term quite interesting, Franken algorithms. So what you do a lot in these areas, you assemble things from building blocks. And you get quite complex systems, and you may not quite know what these systems are doing when you have assembled all of these blocks. And then you think about how do you make sure that it does that? How do you audit these kind of things? And this is actually quite difficult. There's no such thing as software auditing at the moment. So if you have any sort of software in your operations and somebody comes, prove to me that this software works correctly, doesn't make any mistakes, doesn't disadvantage somebody, you will have a hard time to actually do that. And if you go into AI, it becomes even harder because now you have not only software that runs these things, you have models that you have generated from data on top of that. And later in the talk about responsible AI, I think Moira will touch on regulation. So if regulation in this space comes, this is the kind of stuff we have to think about. How do we make sure that what we do can be audited? The responsible AI, this is where we think about how responsible behavior, responsible use of AI affects us. And you know, obviously, about GDPR. This is the data privacy angle. So the data that goes into AI systems has to come from somewhere. And you know all the stories about Facebook and Cambridge Analytica and the misuse of personal data. And frameworks like this are supposed to prevent this. But it's not only using the right data that you're allowed to use in this context. It's also about thinking of the effect, things like fairness. And bias is a topic that appears again and again in the discussion. And bias means that if you go back to your data, that some groups in your data are over or underrepresented in a way that it shouldn't be. So this goes right back to the testing of data. Do you understand what is in your data, and does it represent what you model and what you later will your AI apply to in a fair way? That could be about fairness, but it can also be about performance, and it could impact your brand. So if you have biased data that leads to biased models, it might affect your brand when you use it. So I want to talk a little bit about the use of AI in the future and what sort of scenarios we might see. There's a lot of talk about automation, and Nicola will later talk about it in a kind of how it will affect humans, but what sort of scenarios might we see in terms of AI automation? And this is an interesting one here. So if you go on YouTube or BBC News here and look for Ocado Warehouse, if you haven't seen it, it's quite interesting. So Ocado is a supermarket. You can order stuff, and they deliver it to your house. But actually what they do is they build warehouses. They're not a supermarket. They design and deliver warehouses. And what they have done here is they have built a grid. And within this grid, you have stacks of boxes. And in the boxes, you have whatever you want to deliver. So in this case, it would be supermarket goods. And on top of this grid, you have these robots that look like fridges. And they can move like rooks on a chessboard. They can go back and forth and left and right. And what they do is, if they want to pick a box with certain items, they have to find the location in the grid. And now there could be several boxes on top of the box they want. So they have to call some buddies. And they come and they take away all the boxes on top and put them elsewhere. And then they can reach down into the grid, pull up the box they want, drive it to the edge of the grid, where it can then be picked and delivered. So this is a kind of automation where you will see kind of menial work disappear, people who drive through warehouses and pick stuff from shelves. So these kind of things you can do with these sort of automation and robots. This is another type of automation that we'll see, and it is already in use. So this is software that can read contracts, and it can understand where's the important information in the contract and highlight it. And this is important for people, legal profession, finance, whatever. You have to, where you actually have to go back to documents and understand what's in there. So which of my 20,000 contracts that I have certain obligations? I want to find them. And I'm sure most of you will not have a nicely tagged database, but you might have scanned documents in there, or maybe still on paper. Right? So, and these kind of tools then help. You can scan the text, do optical character recognition, and then the machine can read it and highlight the stuff that is important by training it up. So you train it up with the kind of domain and the kind of stuff you're looking for. And this reduces menial work of experts. So it's a typical human-in-the-loop activity where you have somebody who's highly trained in a profession, but they have to do menial work. They have to read stuff like contracts. And after 100 contracts, then they switch off. Right? So you lose concentration, you make mistakes, and this is where AI can help. Another scenario about not autonomous cars in this case, but autonomous trucks. This is a scenario that Uber is thinking about in the States. So obviously you have long stretches, the trucks have to drive on highways, and you could think of autonomous trucks doing that. Driving on a highway is not so difficult to implement, but it gets difficult if they have to drive into towns. So the idea here would be that you have hubs outside the cities. The trucks drive autonomously between the hubs via the highway network, and in these hubs, human drivers take over, drive the trucks into town, so you don't have to worry about all the messiness of towns and town traffic and pedestrians and bicycles. And they help load, unload the trucks, drive them back to a hub, and they go off on their own again. Another human-in-the-loop scenario on a different type of work. And this sort of automation is fresh from China. This is the first AI anchor or virtual anchor. Those of you who are old enough might remember Max Headroom. This guy is a bit slicker. And so this is a completely artificially created character that reads news. And they have taken a human as a template, and so all the animation is done based on the text. So the text is read out, and the character is animated based on what the text says and how it should be pronounced and what the facial expression should be. So these things you can do these days. And this is the kind of stuff that's behind it. It comes from these so-called deep networks, a kind of neural network technique that was invented in the 70s and 80s and now comes to life because we have lots of compute power and slightly better algorithms, if you like. So what we see here is we see the input is basically an actor, a person who makes some facial expressions, and then these facial expressions are mapped to another person. So the lady that is in the output column, the facial expression of this lady are created by the input character. And so you see examples here. So you can basically now puppet a real character through this sort of technology. So you could take Obama, make him say what you want. The kind of things that you see today, a lot of the interesting and impressive things come from images, videos. And there's a lot of stuff that's happening there. And that seems to be, if you look at it, surprisingly sophisticated and almost easy. If you go to voice, it's very tricky still. So why is that? Why is images easy and why is voice tricky? And voice is kind of the tip of an iceberg, right? Under voice, there's language, there's understanding, context, knowledge. So there's a massive area underneath that you need to work with in order to produce or understand spoken language. And the kind of gadgets that we see, like Alexa, if you look up if you get the slides, click on it, quite interesting. So how people interact with these systems. One thing is, if something talks like us, we think it's smart. Right? So if a machine talks like a human, we think it has human capabilities. It's typical anthropomorphization. So we think it has more capabilities than it actually has. So in fact, these machines are not very sophisticated yet. But we'll see them pushing into our homes. So we call it edge AI. So the idea of that you have devices that become smarter and smarter because you build more capabilities into them. So the next version of Alexa will have a screen and a camera. So it will not only talk to you, it will look at you, see what you're up to in your lounge, and interpret your behavior. It gives you extra services like you can make video calls and stuff like this. You can ask it things, show me, whatever. Instead of what's the temperature, it can show you a weather map. So you get more interaction with these kind of devices. And it's not only Amazon, it's Facebook pushing into your home, and you see providers like Telefonica who use them to bundle their services under one kind of device. So you can use the Telefonica device to configure your mobile, your broadband, your TV, and your internet. So the interesting question is, where will this go? Will this push further out in terms of the interfaces that we see with these systems? So you could think of humanoid robots, right? And they're around, people experiment with them. And now they're not only talking like us, they also look like us. So we think even more they have human capabilities. So of course they don't. It's just a chatbot with a face, and the dialogues are scripted. So the abilities are not there. But we might see these kind of robots or devices popping up and interact with us socially. And it's not only humanoid ones, it's more like cartoon characters and so on. So there's a lot of stuff happening in this space as well. And this will go into the kind of daily life. So not so much in a corporate context, but your customers will interact with these things in their homes. The kind of outlook I want to finish with, the interesting thing for us is, how do we make sure that these AI systems do what we want them to do? How do we understand what they're doing? And the kind of interesting research area in this space is called explainable AI. This is the idea that an AI system not only creates a useful output that you can use to make automated decisions, but it can also explain to you why it came to this decision. And you can use it to have an audit trail. And say, okay, I made this decision because I used this data, this is what I learned when I was trained, and this was the context when I applied it, and therefore I reached this decision. And you can use it to become better, to train your systems to be better, but also you can forensically understand what happened if something goes wrong. So this is one of the kind of research trends to monitor. All right, that's me done. If you have any questions, I'd be happy to answer them.
Thank you very much, Detlef. Any questions for Detlef at this stage? There was one on Slido early on, maybe just in 60 seconds. There was one question that was, what's the difference between artificial intelligence and augmented intelligence?
Yeah, so if you heard Robert's talk, he talked about Iron Man and Terminator, if you remember that. Augmented means human in the loop. Right? So you build some AI that is used together with a human capability to achieve a better result. So, for example, this contract reading application for the legal or financial profession, or if you have a system that interprets things like x-rays in the medical profession, then it doesn't do this without the medical expert. The result from these AI systems is then taken into account in the decision-making by the human. This means augmentation.
Excellent. Thank you very much, Detlef. And you made the point about the importance of access and clean data. So a quick polling question. So for those of you who need to re-log in, www.slido.com, BTAI is the password. So AI needs good quality data to work. What is the state of your data stores? Is it in great shape and ready to be used in AI solutions? Is there some improvement required, but you're getting there? Or is your data locked away in operational systems and is difficult to access, so it's very much siloed? Or have you had enough of data? So quick poll. 30 seconds. Overarchingly, still some improvements needed. So I think, Detlef, very much on what you said, and your triangle there, the challenge of really having clarity over data and the access from the top to the bottom. So thank you very much, Detlef. Can I have a quick round of applause, please? Thank you.